let's start. 1 second. First of all, up to now, in the web information retrieval course, we mostly focus on the search part, right? We want to find the query. Sorry, we want to find the response to a given query, to a given search query, in a corpus of document that it is the web. So usually search means that you have a pretty good idea in mind on what you are searching for, at least in most of the cases. So usually you have a rough idea of what you are looking for, while on the other side you can have recommendations. Namely, and usually searching is something started by the user, right? I mean, you write down the query on Google or whatever, and you submit the query to the system that will get back you items. On the other hand, today we will talk about another major category of services offered on the web. So the recommendations, which basically, again, the assumption is that you have a very large catalog and you want to provide the recommendation about some items in this catalog, okay? You easily imagine a number of, sorry. You can easily imagine a number of online services that you use every day that provide such kind of feature, like, I don't know, I think Amazon or Netflix or most of the YouTube or most of those services that you see on the right. Okay, so what is the idea here? The idea is that in particular, if you compare online recommendation systems with, I would say, usual way of providing products to the users, namely, I don't know, shelves in physical retails. The main difference here is that you move from scarcity to abundance. Even if you have a very, very big retailer, a huge mall, most likely is only a very little fraction of the possible products that an online retailer can provide you. Since the main constraint of physical store is the space, namely the availability of shelves over exposing product, and since the space is a scarce resource, so you have a limited number of products that can be actually shown in physical stores. While in internet, basically, you do not have this problem, right? Because basically you have space is not anymore a limit. Not only, if you consider the cost of dissemination of the information, namely, how can you advertise, actually, the abundance of products that you have on the internet, again, this is for free, while if you have to do similar stuff on physical retailers, the traditional methods are extremely costly. Okay, so there is a completely shift in the paradigm, which is actually well represented in the so-called long tail. So let's have a look here to this picture. Assume that you have the titles. In this particular example, we are talking about a service named Rhapsody, which provides songs. Okay, but you can easily think about similar pictures for all the online services. So you have titles ranked by popularity, and then you have the number of plays of that particular song over time. Okay, so you see, you have very few songs that are listed that are played often, and a lot of songs that are played only very few times. Okay, that are not very popular. Okay, so clearly, if you have a physical store, you have a limited amount of space, so a good strategy is to select a cutoff point, which basically allows you to say, okay, this is the physical space available in my store, and I will most likely show only the most popular products, because those are the ones that more likely will be listened by the users, and so more likely will be sold. Okay, this makes sense? Well, if you are online, because of the arguments we discussed before, because of the fact that basically you are not paying anything, space is not anymore a scarce resource. Digital copies of songs do not basically occupy space, so you can provide the whole catalog. Now, what is interesting actually is that if this is the physical store and this is the online store, most likely this area over the so-called long tail can be even bigger than this. So if you look at I would say, the possibility of selling those songs that are only rarely listened by users, but you can provide them as a possibility to the users, something that you cannot do in the physical store, you can have a business here, right? Because in principle, you can get even more than with the popular songs. Okay, this is the whole idea, and you see that indeed, depending on the type of service that you are going to provide, if you have songs, if you have Amazon.com, or if you have Netflix, what are called obscure products, namely products that are in the long tail, that are not visible in the physical store, are not provided in the physical store, can give you up to 57% of the opportunity. Okay, so this is the story, and this story clearly requires a suitable technology in order to make visible those products to the end user. Since those are very rare products, you cannot expect that people will search for those products, because most likely they don't even know the existence of those products. That's why recommender system, namely a technology which allows you to recommend to user possibly interesting products, is extremely important in this long tail picture. Okay? There is a kind of story of, as an example, titles. One of these is Touch the Void, which is basically presented in the example made by the Stanford professors. That was a very unknown book, but then because of recommended system, a new book, now sorry I don't remember the title, becomes very popular, and thanks to the recommended system, this Touching the Void was suggested because similar to the ones that became popular, and actually at the end, these Touching the Void books became even more popular than the book that has been recommended at the beginning. Okay, so this obscure product can become even more popular than the ones that you initially start providing, thanks to the ones you initially start providing recommendation to the hidden ones. Okay, good. So now What kind of recommendation can we have? Okay, basically the traditional recommendations are the ones made by experts, right? So you have Ask Expert, a kind of editorial board, which review items and provides recommendations on those items, either because they are the favorite ones in some particular category, for a particular category of users, or because they are the essential one. I guess you saw a number of times the most essential, I don't know, 100 books you have to read, or the most essential 100 songs you have to listen, or rock songs, pop songs, and so on and so forth. This is a kind of example of editorial hand-curated selection recommendation system. Or you can have aggregates, again. Maybe you simply look independently from the category of the user to the topmost viewed or read or sold items, the most popular or the recent upload. The main distinction here is between recommendations that are provided independently from the user, or recommendation that takes into consideration the individual user. Okay? And this is actually the kind of recommendation that we want to talk about today. So we are not talking about recommendations that do not consider your specific characteristic. We are talking about a recommendation in which the user is important. Okay, let's define a very simple yet useful formal model. You have a set of customer, X. You have a set of item, S. And what then you have an utility function, namely you have a matrix in which you have a user, you have items, and for each entry in this entry you have a value here that represent the ratings of that given user for that given item. Okay? The rating can be from Boolean, I like it, I dislike it. So the classical kind of evaluation system provided as an example by Facebook. 2 stars, the classical example provided by Amazon, or whatever in between. Okay? So what you usually have is that R is a totally ordered set. Okay? So at the end, you have something like this. So as an example, in this particular case, you have movies, avatar, matrix, and so on and so forth. You have users. And as an example, clearly, Alicia likes avatar, and she doesn't like so much matrix, and so on and so forth. And this is the same for all the other users. Now, what is the main problem here is that, okay, good, I have data about some users. Unfortunately, this is usually a very sparse matrix, right? Because I don't know anything about most of the users. And actually, I'm interested in recommending to people that didn't already evaluated that item. So the main question here, the key question in recommending system is how to evaluate what are blank cells in the utility matrix. Okay, well, so what should I put here in order to represent what is the ranking of, I don't know, matrix for Bob, and so on and so forth. Okay, that's the crucial point. Okay, so the key problems are basically 3. The first one is how to collect the ratings from the users. Okay, So basically, even if this is a sparse matrix, we need some data in order to start, and so we need to collect the evaluation of at least some users. The second problem, which is actually the most interesting, is how to extrapolate the unknown ratings from the ones I already know. Look that we are not actually interested in all the ratings, because we are not going to recommend an item that most likely is not, the user will not like. So basically, what we need is a technique which allows us to build a very accurate representation of the I ratings. And OK, it's important to have a representation of all the other ratings, but less relevant than the I ones, because the I ones are the ones that we can actually use in order to provide the recommendation. Okay? Does this make sense? Clearly, I'm going to recommend an item. When I guess the value for a given user, this value is I, namely represents that at least in principle, the user could be interested in purchasing or getting that item. Okay? So basically, we are not really interested in knowing what are the products or the items that you don't like, but we are really interested in knowing what you like. Okay? Finally, we need a way in order to evaluate the performance of our system. So we need a way in order to see whether our guess about the unknown value is good or bad, or to what extent is good or bad. Namely, we need a measure of the performance, of the success of the performance. Okay, let's start from the beginning. Okay, the most straightforward approach is to explicitly ask to the user their evaluation. Okay, there are some problems behind this approach, but clearly this is the most straightforward. Out of curiosity, how much of you will actually leave a rating on a purchased item, on Amazon as an example? Just out of curiosity. 2 or 3. So I would say less than 10%. Okay? Okay, this is the evidence that actually, if you only rely on explicit rankings, on explicit evaluation, most likely your system will never work because basically you miss value. Okay? So indeed, only few people will leave ratings, and even less people will motivate the ratings with some kind of explanation. So basically, people do not want to be bothered. You can possibly pay people in order to leave their rating, but again, anyway, because of the fact only few people leave comments, because it's anyway, whenever you ask two people to do something, it's a time-consuming task and it's very complex. The main problem of this approach is that it does not scale up, mostly because people will not leave their comments. Okay? So the other alternative, on the other side, you can think about implicit recommendation. The idea is very simple. If you are going to actually buy something, you are actually going to buy an item, most likely this is an implicit message that you like that item. Okay? So even if you are not going to leave an explicit evaluation of your rating, most likely the fact that you do some actions, the most evident one is that you buy the item, means that actually you are interested in that item. Unfortunately, this is a kind of tricky because while this is likely true, I mean, there is some kind of correlation between the fact that you buy something and the fact that you at least like something when you buy it, which does not mean that actually you will going to recommend it afterwards. But anyway, even assuming that this is true, this is not true for low-ranking items. How can you guess the low ranks? Okay, we already discussed anyway that we are more interested in evaluating high ranking rather than low ranking. So this is a problem. We have to take it into consideration, but to some extent we can also consider that this is, we are in the context in which we are more interested in high ranking evaluation than in low ranking one. Clearly you can combine both the approaches, and this is actually what most of the recommender system do. Okay? So putting together implicit and explicit ratings. Okay, now, assuming that we have collected those ratings somehow, the most fundamental question is that we want to evaluate the ratings of a user for a given items that has not yet been evaluated by this user. We have to consider that the utility matrix R, the matrix which connects the rating of a user to a given item, is usually a very sparse matrix for the simple reason that consider the items that are on Amazon, are, I don't know, maybe millions of products. I think that each user will only focus on hundreds, maybe thousands of products. So it means that the matrix is very sparse. Not only you have a problem of cold start in this utility matrix, namely whenever a new user appears into the system, you don't know anything about his utility matrix. And similarly, whenever a new product will appear into the system, you don't know anything unless you need that at least one user will actually evaluate the product in order to get something. Okay, so you have those two problems. But anyway, you have three main approaches in order to estimate this utility matrix. One is the content-based. Another one is the collaborative one. And finally, the latent factor-based. And we will see that at the end that actually a system capable of combining together all those approaches is the ones that has been proved in some specific context, in particular the Netflix context, to be the most effective one. But now the plan is to explore all those three approaches for recommender system. Okay? So, let's recap. Are there questions? Let's recap. Search meaning having, to some extent, a good idea of what you're looking for. Recommending means that on a huge catalog of possible items, the system is going to suggest you something that possibly you didn't think about. Okay? Good. Why is this very important in nowadays economics? Because thanks to the digitalization of assets, basically we have this long tail phenomena. Okay? Space is not anymore a scarce resource. You do not have physical shelves in which you have a limited space to show your products. You have virtual shelves, databases, in which you can possibly show whatever you have. Okay? It means that now, while in a physical store you are forced to focus on the most popular items, in these virtual stores you are free to show everything. Okay? But the question is that you have a very long tail of products that are very rarely requested by users. How can you show those items to the users in order to make them aware of the existence of something that possibly they are interested in? And this is the main topic of the recommended system. Okay. Those recommended systems so requires basically, we formalize the model, a utility matrix, item and users, And the idea is that now we want to find out a utility matrix of the unknown entries into the matrix, namely the ratings of a user to an item that he or she never saw. To do this, we need the three main components. The first component is anyway, as a starting point, we need some entry in the utility matrix. Okay, and so we need either to collect explicit or implicit ratings. Then we need to evaluate the utility matrix. And finally, we need to evaluate the quality, we need to build the utility matrix. And finally, we have to evaluate the quality of our estimation of the utility matrix. To this purpose, we have basically three techniques: content-based, collaborative filtering, and latent factoring. Okay? So let's start with the first one. Okay, so basically, we focus now on content-based recommended system. What is the main idea here is that you will recommend an item to a given customer on the basis of similar items that the customer has rated highly. Okay, so just to give you an example, if I use Amazon, I don't know, a bookstore, okay, and I always rated very highly sci-fi books, most likely the system will suggest me sci-fi books that I didn't already booked or that are not already in my virtual library. Okay, this is the main idea. Okay, you can have clearly a number of examples. You can have movie recommendation, and this is very clear in, I don't know, Netflix or most of the other movie services, website, blog, news, but also, you know, a similar approach, you can think about a similar approach when, as an example, Facebook will suggest you a friend, okay? You can even think that is a content-based recommendation. Remember that now you know that basically I can explore two kinds of I would say, structures. I need to build a similarity between user documents, movies, whatever. So there must be a relationship between two documents. This relationship can be inferred, like in this case, or can be explicit, like in the web link in which the connection is made explicit. And you saw with Luca that in that case you can use different techniques in order to rank the content, okay? So link-based ranking and stuff like that. Okay, good. Given this idea, what happens is the following. So first of all, you need to build a item profile. So a profile of the items that the user really likes. So a profile of the items that the user evaluated very highly before. So on this item profile, I need to abstract in order to build a user profile. Okay? So just to give a rough example, according to this picture, now you have a circle and a triangle, which are red. So most likely these guys will like red stuff, which are circle and triangle, and also will like circle and triangles. Okay, so that's the idea. And finally, you have this huge catalog or collection of documents, and you want to provide feedback. You want to recommend stuff according to this user profile. And so, as an example, here you have This polygon, which is red, this is a circle, and those are squares, which are something that, at least in principle, match with the user profile. That's the overall idea. Okay? So from the profiles of the item the user likes more, I build a user profile. And according to the user profile, I have to select the documents or the items in my collection that are most similar to the ones in the user profile. Okay? Okay, usually in recommended system we talk about items, but since we came from the background in web information retrieval, most of the time I can use documents or items interchangeably, okay? Basically, we are talking about the same stuff. Okay, so what I have to do, for each item, we have to create this item profile. So we are in the first row on the top. Okay, look, this is actually maybe the most challenging problem in this content-based recommendation. Okay, because as an example, when you have a movie, the profile can be made of the author, the title, the actor, the director, and so on and so forth. A number of information that possibly you have as a metadata, or you have to infer somehow. Okay? If you have a text, we know a bit more, because this is actually what we made in our information, in our information recommendation system, right? So basically, we have to distill a set of words that well represent the document. Okay, we have to extract the features, and now we know how to do it pretty well by TF-IDF. I don't think we have to go through TF-IDF. Simply, I want to remember you that the idea is that we have basically two contributions in order to identify the relevance of a term into a given collection. The term frequency, because the idea is very clear. If a term occurs very often in a document, most likely that term is telling you something about that document. But at the same time, you have terms like the articles, or stuff like that, that appears quite often but do not characterize the document at all. Why? Because they are common in all the documents. So in order to characterize very well the documents, we need to also find out the rare terms with respect to the whole collection. And this is the contribution of IDF, okay? Then you use the logarithmic scale in order to take into consideration that otherwise the weight is too strong. This is clear for everybody. And this is the technique we used in order to introduce the vector-based system in order to make a web search. The idea is I take a document, I transform this document into a vector of terms. I take a query, I transform that query into a vector of terms, and then I need a technique, again, we know it pretty well, the cosine similarity, in order to see to what extent a document is similar to the query. Exactly the same concept here. But we need this concept in order to distill a vector that well represents the original item, namely the original document. And focusing on document, on text document, a good technique is TF-IDF. Okay, good. Okay, now that we have a profile, namely a technique in order to associate to each document a profile by TF-IDF, we need to build a user profile. So basically, we have, I remind you the original idea. The original idea is to provide a recommendation on the basis of document that has been already evaluated by the user. Okay? So basically what I do, I have a vector, a set of documents, I1, A2, A3, IN, with their profile, okay? And we know the evaluation of the user for each of those profiles. Okay? We are here. We know that the user likes those item profile. And these likes means that we have an evaluation, a rating. Okay? So we have this, we have now this, which is basically TF-IDF representation in the case of documents, of text documents. Clearly, this becomes more complex when we have other kind of documents, but in this, let's focus this example on that. So we have the evaluation, we have the item profile, we want to build the user profile. So we are in this step. How to build this user profile? Okay. Possible A, user profile 1. The most simple one is I make the average. So basically, what I do here, I have all the items of the user. Okay, those are vectors. Okay, vectors with, in this particular case, the TF-IDF value for each of the terms. And so what I do, the most simple stuff, to build the user profile. So the user profile is equal to the average. So I divide by n. Okay, this is the most simple way. It is simple, actually. What we do not like in this approach is that it does not take into consideration the fact that we have another information. We have also, no, let's call it R, R1, R2, Rn. Namely, we do not only know what are the profiles, the vector, but we also know what are the ratings. Okay, so instead of doing simply the average, what we can do the average, the weighted average, using the ratings as weight. So R1, R2, Rn. This is maybe more interesting. Okay? And so this is one of the possible techniques in order to build a user profile. Okay, so now this picture should be now clear. We have likes, namely we have this. We have the item profiles. We built it in case of text document items by the TF-IDF representation. We build the user profile, and it can be either the average or the weighted average. Okay, so we miss simply the last step, the match. Okay, so now we have basically, as usual, we have now a vector, which is the user profile. And then we have a number of vectors that are the items. Okay? Does this make sense for everybody? It's the usual stuff. Okay, so what we can do, what we can do now is to use the cosine similarity of the users in order to make this evaluation. But before that, let's make a simple example that is represented in this picture. Okay, two simple examples to simplify, to make clear what are the possible techniques. Okay, example number one, the most simple, is the so-called Boolean utility matrix. So as an example, you have a matrix in which the items are movies, and you have 0 or 1, depending on the fact that one actor is in that movie or not. Okay? So now you, assuming that the user watched in the past, because I remind you that in this particular case we need past evaluation, 5 movies, and 2 movies featuring actor A and 3 movies featuring actor B. Okay, those are the 2 movies. Okay, so now what you can do is that among the 5 movies, the ones featuring actor A were seen 2 times. The one featuring actor B were seen 3 times, and so 2 possible evaluation considering the weight are 2/5 and 3/5. Okay, this is one of the most simple metrics. Okay, instead of having the TF-IDF matrix, in this particular case, I have a utility Boolean matrix in which I have 0 and 1 whether actors actually performed in a given movie or not. It's another example. Okay, does this make sense? One other possible example. So now you have all, again, that kind of matrix, but in this particular case, you have 1 to 5 star rating, okay? So the movie can give you an evaluation from 1 to 5, and let's see, you see that actor A are evaluated 3 and 5, the 2 movies, with actor A are evaluated 3 and 5, while the 3 movies with actor B are evaluated 1, 2, and 4. Okay, so this is something more complex, right? Because, you see, when actor B is present, you have basically 2 movies that are evaluated below the average, and 1 movie that is evaluated above the average. Okay? While when actor A is playing in the movie, you have 3 and 5, meaning that I remind you that the evaluation is between 1 and 5. So 1 is the worst evaluation, 5 is the better evaluation, the highest rating, namely 3 is the average. You consider that movie reasonable but not fantastic. Okay? So when actor A is playing in the movie, basically you say, okay, the first movie I saw, it's so and so, nothing special, but I like it, or I'm indifferent, and I like very much the second one. While here I'm saying I don't like it at all, or I really don't like the first one. I think the second one is not particularly nice, and the third one I like it. Okay. So what you can do in order to better show this situation, to well represent this situation also on the average, because remind that we are building a user profile, okay, in this particular case. So we want to know something that we want to build, to calculate, to compute something that well represent user testes, okay? So one option is to normalize the rating, okay? So what you can do basically is that you normalize the ratings, and so since 3 is their average, is 3 minus 3 is 0, 5 minus 3 is 2 over the 2 movies, and you get 1, okay? Here you have 3 minus 1 is minus 2, 3 minus 2 is minus 1, and 4 minus 3 is 1, okay? So I remind you that 3 is the average, because we have rating between 1 and 5. 3 is the middle, it's something, okay? So look, now the profile weight is a bit different, because in one case, we get 1, which means that if the actor A is playing, actually there is a slight interest on that movie. While if the actor B is playing, to some extent the user most likely will not like very much that movie, taking into consideration the contribution of those two weights. Okay? So the message is the following. You have different ways to build up the user profile, and you have to work on the different ways in order to figure out what is the most effective ones. We saw basically 3 examples. Example number 1, when we have documents, we can build the representation of the documents by TF-IDF and then doing something like the average or the weighted average. Example number 2, the Boolean utility function, matrix, sorry. Example number 3, the star rating. Okay? Okay, anyway, now, once you have finally the profile, okay, so one example that we saw is the weighted average item profiles. What you have to do is you have to predict, and to predict what? Predict what documents are interesting for the user. You build this vector. You have each document as a vector. So what you can do is simply to compute the cosine similarity, as we saw several times. Okay, nothing new in this particular case. Okay, clearly, we made very short a very long story in which there are a lot of room for optimization, but this is mostly the focus on big data computing, okay? So, or massive data set, like in the case of the Stanford class. Here we are more interested in understanding what are the ideas behind this content-based recommendation system. Okay, so again, keep in mind this picture. We have some items that have been evaluated by the user. By those items, we build the profile. And we use this profile in order to compute the similarity of the user profile with the items in order to recommend the items that are the most similar to the user profile. That's the whole story. Okay. Okay, what are the what are the advantages of this approach? You do not have the problem of cold start or sparsity, okay? Because basically, why we do not have the problem of cold start? Because basically, as soon as you plug into the system, as soon as you put into the system a new item, this item can be considered because you have simply to extract the features. That's it. Okay? Okay. What is also interesting is due to the fact that you are building a user profile, some kind of user profile, basically you can take into consideration, according to the user profile, some very specific and unique tests. Okay? Even outliers, providing that you have a past history of those outliers, namely that you have some evaluation of those outliers, can be well represented by a user profile. Again, similarly to what we said at the beginning, you do not have the first-rater problem. We will see later on the other approach, which is collaborative filtering. In collaborative filtering, basically, you are suggesting item on the basis of similar users, of the suggestion of similar users. In that case, you need somebody that gave you the rating in order to start. In this particular case, again, if a new product will be in the collection, you simply compute the feature representation of this product, and you have the vector that will allow you to provide the recommendation. And since you have this vector, you can show to the user a kind of explanation of why you provided that recommendation. Okay. So as an example, again, the example we saw before, since in the past you read a lot of time sci-fi books, I'm going to suggest you this new sci-fi novel because I know that you like it. You like this kind of books. Okay, so those are the main pros. What are the cons? Good. In some cases, and this is probably the most difficult problem, is, well, the first two are the more difficult problems. Extracting feature is not so trivial. Okay, we say, look, I have a film, I have a movie, and I want to get the author, the title, the director. Good, very nice, but this assumes that you have some kind of meta information. If you have to extract it from the raw material, it's very, very tough. And this is applicable to most of those digital content. Okay. The second problem is, in order to start, you need some kind of raw initial profile. You need a way to represent the user. Okay, if this guy will never, it's starting today, okay? I'm a new one. We saw that we do not have any problem with the item. As soon as an item appears in the collection, I compute the feature and I can recommend that item. But when a new user appears, what happens? Okay, in this particular case, what you can do, maybe the most intuitive technique is that you build an average profile for the user. You start providing recommendation on the basis of that user profile, and over time, according to the user ratings, you will evolve towards a system that is more similar to the ones we have discussed. Okay, this is the user approach. Okay. The main problem that you have is that you can have over-specialization. You know, okay, if you like I don't know, the example, you like the Harry Potter 1, Harry Potter 2, Harry Potter 3, it's very simple to say that you will likely love Harry Potter 4. That's not particularly interesting, right? So basically you have something that is a kind of over-specialization. You tend to recommend something that is natural for the user, but you are not really giving something that will make wider the horizon of possible content he or she is interested in. Okay, this is the main problem. And there is another very important question that brings us to the next step, which is collaborative filtering. Okay, we say the user gives me ratings about some items. I will use these ratings in order to build a profile. Good. But why cannot use those ratings in order to give suggestions to other users? This is absolutely something missing in this system. I have a lot of information, namely the rating, quality judgment of the other users that I will never exploit in this content-based recommendation system. Okay? So this is the topic for the next, argument. Let's relax for 10 minutes and we'll start again with collaborative filtering. Questions? Okay.